Glider 5.2 Glider Performance. Now, let's delve into the realm of weight and its pivotal role in shaping the performance characteristics of a glider. Unlike lift, drag, and glide ratio, which are inherent to the glider's design, weight is a variable under the direct control of the pilot. This parameter holds the key to a myriad of flight dynamics, and understanding its implications is essential. Increased weight serves as a double-edged sword, affecting various aspects of glider performance. During launch, a heavier glider grapples with an extended acceleration period due to heightened inertia. The prolonged climb-out phase further accentuates this challenge, as the glider must lift a greater mass to altitude. The resulting impact on takeoff distance and climb-out rate is vividly visualized. As we explore the stall characteristics, a heavier glider reveals a higher stall speed and minimum controllable airspeed compared to its lighter counterpart. This intricate relationship becomes evident when we consider that doubling the weight results in a stall speed increase of more than 40%. The consequential adjustments during circling and thermals become apparent, as the heavier glider faces challenges exploiting the lift of the thermal core due to its increased stall and minimum sink airspeed. Conversely, in cruising flight, the advantages of increased weight come to the fore. The heavier glider, despite its higher stall speed, can achieve faster airspeeds while maintaining the same lift-to-drag ratio. This characteristic is particularly advantageous for cross-country flying and racing, where higher speeds are desirable. To facilitate increased weight for specific flight conditions, gliders often incorporate ballast systems, allowing pilots to add or jettison water to modify the glider's weight. While ballasted gliders exhibit reduced climb rates in thermals, their advantage during cruising flight compensates for this drawback. An essential consideration is the prudent jettisoning of water ballast before entering the traffic pattern. This strategic move not only facilitates a normal approach and landing but also reduces the landing gear loads by lowering the glider's weight. In conclusion, the intricate dance between weight and glider performance unfolds across takeoff, climb, circling in thermals, and cruising flight. The pilot's strategic control over weight allows for nuanced adjustments, optimizing the glider's capabilities for diverse flight scenarios. As we navigate the skies, the significance of weight becomes a central theme in the symphony of glider aviation. Alright, let's simplify the talk about glider performance without getting too technical. So, when it comes to glider flights, a lot of things affect how well they go up or down. When we talk about going up, it depends on how the glider launches. If it's from the ground, like with a winch or tow vehicle, it can shoot up really fast, sometimes more than 2,000 feet per minute. If it's getting pulled by a plane, the climb speed depends on how strong the plane is. Some gliders can even launch themselves. They have engines on board. How fast they climb then depends on their design, the power they have, and how heavy they are. Now, every glider comes with a guidebook called the Glider Flight Manual. It's like a superhero handbook for gliders. It tells the pilot everything they need to know, from how to put the glider together to how much it should weigh. In the cockpit, there are little signs, placards, that tell the pilot important stuff. The fancier the glider, the more signs it has. They show things like how fast it can go and how to handle different situations. Speaking of speed, there's a sweet spot for gliders. Not too slow, not too fast. The handbook and these speed secrets are all in simple charts and graphs. They show the glider pilot the best speed to climb, the best speed to glide, and other cool tricks to make the flight smooth and fun. Alright, let's take a closer look at the Glider Flight Manual and understand the weight and balance information. The Glider Flight Manual, GFM, is like the glider's handbook, providing key details about its weight and balance. This information is critical, especially when the glider is fresh from the factory. However, any alterations made to the glider, such as maintenance or adjustments, can significantly impact its weight and balance. Pilots document these changes in the airframe logbook and on relevant cockpit placards, like noting a maximum fuselage weight of 460 pounds. Weight is a pivotal factor in both the construction and operation of gliders. It requires careful consideration from all pilots. Maintaining proper weight management is crucial, and overloading the glider can have serious consequences. Every glider comes with operating limitations, akin to rules in a game. The VG diagram serves as a visual guide, outlining the design limitations of the glider, including maximum speeds and load factors. Pilots must acquaint themselves with all operating limitations specific to each glider they fly. The above visual shows 4 possible conditions in the fundamental flight envelope for a high-performance glider, giving pilots a clear understanding of the glider's capabilities and restrictions. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.